Assalamualaikum warahmatullahi wabarakatuh. For the introduction, locating exit faults in underground cables is crucial for minimizing outage times and reducing repair costs. In this presentation, the techniques such as the Murray loop test and the tamping method, which are used to detect open circuit faults, short circuit faults, and earth faults. These methods, along with single end measurements, impedance calculations, and traveling wave analysis, it will ensure efficient maintenance and enhance the reliability of power system. Plus, it will provide accurate fault location, which are important for addressing both incipient and permanent faults, thereby ensuring a system stability and reliability.
So for the three fault of underground cable, the first one is open circuit fault. An open circuit fault occurs when there is a break or discontinuity in the conductor. This can be caused by various factors such as mechanical damage, corrosion, and manufacturing defect. When an open circuit fault happens, the electrical part is interrupted, resulting in zero current flow through the affected conductor. So for the second one is short circuit fault. When two multi-core cable wires come into electrical contact with each other, it results in what is known as a short circuit fault. This type of fault occurs when the insulating material between the conductor degrades or is damaged, allowing the conductors to touch each other. This contact can create a path of lower resistance for the electrical current, leading to an abnormal increase in current flow. Last but not least is earth fault. When those wire goes under contact for those ground, it will be known as ground fault. This failure occurs when the outer shell is damaged due to chemical reaction with the ground and mechanical vibration and crystallization.
Next, we move to the difficulty to locate the exact location of fault. There is a small probability that the cable used for subterranean electrical distribution system may malfunction since they are buried or housed in ducts. Three main forms of faults can still occur with the cables. There are few difficulties to locate the exact location of the fault. Here are four main difficulties to locate the exact location of the faults. First is the inaccessibility. Subterranean positioning make cables hidden and hard to access. The presence of the other underground utilities such as water pipes, gas lines, and teleconnection cable can obstruct and complicate access to the faulty cable. Next is the signals issues. Electrical signals weaken over long distance, hindering precise fault location. It also signal also can be distorted by electrical noise from nearby cables or external source. Next, environmental factors. Soil type, moisture content, and temperature variation also affect the cables and fault electrical properties. Weather changes can impact the underground environment, complicating fault detection. And lastly, in its equipment and expertise. Specialized equipment is expensive and requires maintenance and calibration. And lastly, skilled technicians are needed to accurately interpret test data.
For the Murray loop test, what is the Murray loop test? The Murray loop test is used to find the fault location in an underground cable by making one Wheatstone bridge in it. A current is injected and a variable resistor is adjusted until the bridge is balanced. And by comparing the resistance, we shall find out the fault location and the resistance ratio from the setup, making it effective for pinpointing short circuit fault and earth faults. For the principle of Murray loop test, the Murray loop test is used to locate short circuit faults and earth faults in underground cables. it operating on the principle of a balanced Wheatstone bridge. For both fault types, a bridge circuit is created using the faulty cable and a non-good cable, and the current is injected into the loop, and a variable resistor is adjusted until the bridge is balanced, at which point the resistance ratio between the known and unknown cable segments is determined to help calculate the distance to the fault. As the resistance of the cable is proportional to its length, for short circuit faults, the cables are simply connected in a loop, while for earth faults, one end of the faulty cable is grounded, ensuring accurate fault location by measuring and balancing resistances within the loop. Now let's look at the advantages and disadvantages of Murray loop test. For the advantages, the Murray loop method is relatively simple to implement and does not require sophisticated or expensive equipment. And the second, for specific types of faults, such as low resistance faults, the Murray loop can provide accurate results, helping to pinpoint the location of the fault effectively. And the third, the method operates at low voltages, which reduces the risk of further damaging the cable or causing safety hazards during the testing process. And for the disadvantages of Murray loop test, the effectiveness of the Murray loop is limited when dealing with high resistance or intermittent faults, and it may not provide accurate results for these types of faults. And the Murray loop test need access to both ends of the cable, and it also very necessary. And this can be inconvenient or impractical for long or inaccessible cable runs. And the method can be sensitive to external factors such as temperature variations and the presence of the parallel path in the circuit.
Tamping is a method used to locate fault in underground cables, especially for high resistance fault. They are not easily detectable by other means. The process involves discharging a high voltage pulse, a thumb, into the cable, which generates a loud noise or mechanical shock at the point of the fault, like in this video. So for the principle of tamping, the tamper locates fault by using a charged capacitor to create a high energy pulse between the faulted conductor and ground. This pulse is intended to create an arc at the location of the fault. The arc hits the surrounding air and the energy is released as an audible thump. The arc location can be traced by sensing the acoustical thump, the seismic wave, or the magnetic field generated in the arc. The thump is created when the current in the arc hits the air, causing a pressure wave to expand outward from the arc channel. The initial current surge causes the air to expand much faster than the energy can propagate away from the arc channel, resulting in an enormous increase in pressure and thus creating a shock wave. For the advantages of thumping, the first one is very accurate for pinpointing fault. The second one is easy to learn with minimal training required, mostly safety and operational training. The last one is can be combined with other techniques like pass ego to reduce stress and on cables. For the disadvantages, the first one is it is extremely time consuming, can take hours of or days to locate the fault. The second one is the repetitive tamping can reducing the cable's remaining service life. And the last one is ineffective for bolted fault that short where there is no gap for arcing.
And lastly, we move to the conclusion. Locating faults in underground cables is essential but challenging due to their hidden nature, various fault sites, and environmental conditions. Two common methods are the Murray loop test and tamping method. The Murray loop test uses a Wheatstone bridge circuit to measure resistance and find faults, making it accurate and cost effective, but requiring a good cable and accessible ends. However, the tamping method sends a high voltage pulse through the cable, creating a sound at the fault location, which is easy to detect and effective for different fault types. However, it can cause further damage, noisy, and require skilled technician. Both methods are useful, and the choice depends on the specific situation and available resources. Thank you.